The thing that makes OpenClaw exciting is also what makes it risky. This is not just a chatbot waiting for questions, it is a tool using Assistant that can touch accounts, files, browsers, channels, plugins, coding agents, and background workflows. Once an assistant can operate like that, the security question changes. You are not only protecting a prompt, you are protecting a credentialed operator with memory, tools, and the ability to act. The risk loop is simple. Untrusted instructions meet executable tools while the agent is holding persistent credentials. OpenClaw's Codex harness documentation makes that trade-off visible. One posture is a trusted local operator mode with no native approval prompts and broad permissions, built for unattended progress. The other posture is Guardian reviewed, workspace write access, on-request approvals and automated review when the agent wants to leave the sandbox, right outside the workspace or add permissions. That difference is the whole security harness story. The browser harness is where this becomes tangible. It lets an agent use a real browser for dashboards, forms, logins, and sites that normal scraping cannot handle. That is useful, but a browser that can log in can also leak credentials or take the wrong action. The practical controls are not glamorous. Use read-only APIs first, keep passwords out of task text, run the browser in a sandboxed profile, cap the number of actions, and review the action log while tuning. Self-hosting is not a magic security boundary. It can keep data and keys on infrastructure you control. But the operator still owns credential scoping, service accounts, skill review, channel allow lists, file permissions, and key rotation. That is why the better framing is lifecycle governance, not prompt filtering alone. A filter at the front door does not control what happens when a tool result is persisted, when a skill runs, when a message leaves the system, or when a subagent is spawned. The recent security research points in the same direction. A systematic evaluation of OpenClaw-style agents argues that agentized systems can be riskier than the same models used in isolation, because tool use, multi-step planning, runtime context, and execution capability interact. The Prism paper makes a similar point from the defense side. It treats runtime security as multiple hooks across the agent lifecycle, with tool policy, path controls, private network restrictions, outbound secret checks, risk accumulation, audit logging, and hot reloadable policies. The harness also needs a clean approval policy. Low-risk reads can run quickly, but risky actions should stop for review. That means external sends, account changes, broad file writes, permission upgrades, tool installs, and anything involving secrets should require an approval trail. The goal is not to slow every task down, it is to make the expensive mistakes visible before they become external actions. So the practical checklist is straightforward. Run the agent away from your main workstation when the data matters. Use dedicated service accounts and minimum scope credentials. Review skills as privileged code, not harmless add-ons. Restrict messaging channels with allow lists. The unresolved question is not whether agents can do useful work. They can. The test is whether the runtime can keep strong boundaries when instructions, tools, memory, credentials, and external content all meet in one loop. The bottom line is straightforward. Autonomy requires boundaries. Governance beats filtering. Isolation protects identity.